Happy weekend!
Hello.
Saying hi, George. Peekaboo. We're gonna get into lesson 18 here, and in lesson 18 we're going to continue. Oh, Cal's so excited. Oh, man down. We're going to continue estimating, rounding our division expressions and estimating, but the difference here in lesson 18 is that we're going to have double digits numbers as opposed to before we were looking at single digit numbers. So we're just going to continue using the estimation as a guide. The check step is going to be critically important now. George just wants to touch all the buttons. I hope you guys are having a great weekend. We're getting excited for the Bears game tonight. Go Bears! And I'm gonna actually be going to Soul Cycle here in a little bit. But we figured we can get the math video posted so you guys can get your practice in. I've also been grading our celebrations of learning, and they look really, really good. I'm so proud of the work that you guys. We are looking at. Oh, this is kind of funny. L18 on 11, 18, 18. What are the chances? Sorry that the intro was cut a little short. Cal came in and came in real hot, so I had to edit some out because we had a little bit of an altercation between the boys. Anyway, everyone's fine. We're ready for math, and let's check out the instructions here. Estimate the quotients for the following problems. The first one is done for you. Wow, thank you. So here we have 5,738 divided by 21. We rounded 21 to 20, and then rounded 5,738 to 6,000. And then we're looking at 6,000 divided by 20, which is 300. The way, of course, that we can check that to make sure that all of our zeros are in the correct place is by multiplying the quotients by 20. So we've got 3 times 2 is 6. And then we're bringing along 3 zeros. And we want to see if this number is the same as this number. And indeed it is. So great job, Eureka. Also, you guys, on Friday we talked about, I think a lot of us are still in the pattern or habit of bringing zeros along. That was multiplication. This is, you can sit here, Cal. You sit right next to Mama. No, Mama can't hold you while I'm doing my work. That is not the case in division, you guys. In division, you can sit right next to me, Cal. You can sit right next to me, baby. So what's happening, you guys, is that... What's wrong, honey? Sugar, you're fine. What's happening is that when we divide by 20, the digits are shifting to the right, one place value. So what's happening is that this last, or I guess this 0 that's furthest to the right, is falling off the edge. As it shifts to the right of the decimal place, it's shifting this 0 shift into the 10th place value, and a 0 in the 10th place value means that there's nothing. So we talked about the idea that whatever the number is being divided by, that amount of zeros is essentially being eaten. And we know that that's not actually the case. You guys have this amazing place value understanding. We've done all of that work with shifting to the right or shifting to the left and thinking about how many place values numbers shift to the right or the left based on what we're dividing by or multiplying by. So keep that understanding in your pocket and bring it along with you, because that's really going to support our work throughout the rest of Module 2. Okay, so let's take a look at this, you guys. 2,659 divided by 28. I'm going to round 28 to 30, and then I'm going to round this to 3,000, because I can do this really easily in my head. Let's think about 3 divided by 3, which is 1. We're going to shift, there's 1 0 here, so we're going to shift one place value to the right, which means 1 0 is going to shift into 10th place value, and we'll be left with 1 2 zeros. Let's see if that makes sense. Let's check ourselves by multiplying. We're going to multiply 30 by 100 in the hopes that we'll get this number here. Let's see what happens. 3 times 1 is 1. And then you guys with multiplication, you guys know the rule with multiplication, we're going to bring these zeros along to the party. So we have 1, 2, 3 zeros. And indeed. Okay, cool. Let's keep going, guys. Let's go ahead and round this 34 to 30. And then we're going to keep this 9,155. We're going to round that to 9,000 because I can really easily divide 9 by 3 and get 3. Let's see what's going on with our place values. This 0 represents one shift to the right, which means all of these digits are going to shift one place value to the right. Keep in mind, you guys, 9,000, although we don't write it down, 9,000's decimal is right here. That's where the decimal is. We don't write that because it's not necessary. We know that it's there even though we don't write down the decimal. When we shift these numbers to the right one place value, this 0 is going to get shifted to tenths, which essentially is going to budge all these other zeros into ones, tens, and this 9 is going to get budged into hundreds. So all of
out to the puppy.
Oh, ouch, and the puppy's head. Oh dear, oh dear. So when all of these digits shift to the right, one place value, 1, 0 is going to get budged into decimal land, and a 0 in decimal land is completely insignificant. No offense to anyone in decimal land, which means we're looking at a 900. I'm sorry, we're looking at 2 zeros left over. Because essentially what's happening, you guys, is this 1 0 is eating this 1 0. Because this 1 0 is saying, okay, shift to the right one. And this 0 at the very end is bumping the puppy's head. This is really silly. It's kind of sacrificing himself to decimal land. Okay. After that long dramatic story, let's just go ahead and check all of this nonsense. 30 times 300 and see if we ended up on the right side of this. 3 times 3 is 9, and we're bringing 1, 2, 3 zeros to the party. Cross your fingers that this number is the same as this number. Well, essentially, before I sacrifice that final 0 over the edge. 9,000 and 9,000. We are all good.
Puppy head.
Bumps the puppy's head. Cal thinks it's bumping the puppy's head, which is really, really cute. Okay, guys, let's look at another one here. We have 1,463 divided by 53. I want to round that to 50. Hold on.
Which one was it?
Oh, can you ask Daddy to help, please, baby?
Please.
I love those nice words. Oh, do you hear Cal's nice manners? Cal, I'm so impressed. We're going to round 1,463 to 1,500 because I can very easily look at 15 and 5 and think, well, 15 divided by 5 is 3. I have 1 0 here, which means 1 0 is going to get shifted into decimal land, and it's no longer significant. There's 1 0 left there, so we're looking at 30 as our quotient. Before we get too confident, let's just check ourselves. This is such a crucial step, you guys. We're going to check ourselves by multiplying 30 times 50. Keep in mind that division and multiplication are inverse operations or reciprocal operations. We can undo or check one operation. We can check division by using multiplication. 30 times 50, let's think about what that looks like. 3 times 5 is 15. I'm bringing 2 zeros to the party. Is this number the same as this number? Yes! Nailed it. Let's look at this. 2,525 divided by 64. You guys also keep in mind that what I choose to round these numbers to may be different than what you choose to round these numbers to. As you can probably imagine, these numbers, our quotients that result from rounding the numbers are going to be our guiding numbers when we get into a standard algorithm of more complex division problems. We're going to do this first. We'll go through all of this long division, and then we're going to, just like we did with multiplication, we're going to check and see if our final quotient is close to our estimated quotient. So we're not here yet. We're not doing the standard algorithm yet. Right now we're just making sure that our estimation and our rounding skills are on fleek, as the kids say. And we're going to use these rounded magic numbers to check in with our final quotients once we get to standard algorithm. I just want to note that Mr. Calamaris gave me a dirty look when I said on fleek. Yeah, honey, that's what the kids say. Actually, it's probably not what the kids say anymore, but maybe like last year, 2 years ago.
That was what the look was for.
Oh, Mr. Calamaris knows that kids don't say that anymore. So I'm not only an old lady trying to use cool terms, my cool terms are old, which is probably even more embarrassing. Sorry about that. Sorry to embarrass you, honey. Okay, so I went around 2,525 to something where the first two digits can divide very easily by 6. I'm thinking 2,400 because 24 divided by 6, I can do that really, really easily. I know that 6 times 4 is 24 because I keep all of those math facts in my pocket. So 24 divided by 6 is 4. Let's think about the 0 situation. We have one shift because I have 1 0 here, so that means this 0 is going to shift to the right of the decimal, which means that this we'll just have one sacrificial 0 falling over the edge of the cliff. I have 1 0 left, so I will put that in my quotient. Let's check ourselves, make sure that that is working out. We're going to check ourselves by multiplying 40 by 60. 4 times 6 is 24 with 2 zeros. Indeed! Woohoo! Let's look at one more here. We have 72. We're going to round 72 to 70. And then I'm going to go ahead and round 2,271 to 2,100 because 21 divided by 7 is 3. Let's look at our 0 situation. We have one shift. We have 1 0 to the right. So this 0 is getting sacrificed. 1 0 left over. Let's go ahead and check ourselves, make sure that that is coming out roses. 3 times 7 is 21 with 2 zeros. Very cool. Let's look at a word problem, and then I think we're going to call it a day, mathematicians. Okay, buds, we're going to look at this word problem. I don't know if you guys know, but who is responsible here? We're going to say Tyler. Tyler bought 28 apps for his phone, change the pronoun, that altogether used 1,348 megabytes of space. If each app used the same amount of space, about how many megabytes of memory did each app use? Show how you estimated. Okay, so we've got 28 and we've got 1,348. We're going to divide across 28 apps evenly. What are we dividing? 1,348 megabytes. So let's go ahead and round. We're going to round 28 to 30. And then we're going to go ahead and round 1,348. I'm going to round that to 1,500, 1,500. So what we're looking at is 1,500 divided by 30. 15 divided by 3 is equal to 5. We have 1 0 here, which means 1 0 is getting sacrificed over the edge. And by over the edge or sacrificed over the edge, I mean it's getting pushed on the place value chart. If this is the decimal point, so we've got, sorry, that's a little crooked. We've got 1,500. This number, when we divide it by a power of 10, all of these digits are shifting over one place value, which means this 0 is getting sacrificed over the edge, and it's essentially falling to its death. Sorry, it's kind of morbid, but I feel like it makes sense. Which means we're going to have 1 0 left over. So according to this reasoning, 1,500 divided by 30 is 50. Let's just check ourselves. If that is indeed true, also 50 times 30 should be equal to 1,500. 5 times 3 is 15, and we're bringing 1, 2 zeros to the party. Yes. Okay, sweet. We are good. So there's going to be about, is it scary? Yeah, there's going to be about 1,500 megabytes here. Oh, it's scary, Cal. This is so scary. Okay, let's look at B. If half of the apps were free and the other half were $1.99 each, about how much money did Tyler spend? Okay, so he bought 28 apps. We see the word about, so we're going to go ahead and round this to 30 because about means estimating and rounding. Okay, so if half of the apps were free, well, let's think about if you have 30 apps and we divide them by 2. Remember, a fraction bar is the same, represents the same function as division. So what's 30 divided by 2? 30 divided by 2 is 15. So half of the apps would be 15 apps. If we had 30 in all, half were 15. So if half were free, and then if 15 cost $1.99 each, about how much did he spend? Well, let's go ahead, because we see the word about, let's go ahead and round $1.99 to $2. So we're looking at 15 times 2, which is kind of funny because this is the inverse of 30 divided by 2. We'll end up with the same number. 15 times $2 is going to be $30. If half of the apps were free, 15 approximately represent half of the apps were free. The other half cost $1.99. We rounded that to $2. Tyler spent about $30 on apps. Wow, I hope you got some good apps there, Tyler. Secret word, you guys, is what is the silly word that I said when I was trying to be cool and Mr. Calamaris kind of laughed at me. I was trying to say, oh, it's this, according to what the kids say, and I said Mr. Calamaris was sort of making fun of me because he doesn't think kids actually say that word anymore. What was that embarrassing word that I used? That is the secret word. Also, I hope you guys enjoy this crisp, chilly, sunny, beautiful day. I hope the Bears win because if they don't, I'm going to be really grouchy tomorrow. Mr. Calamaris, do you think the Bears are going to win?
Go Bears.
Okay, go Bears. We're keeping our fingers crossed. Enjoy your day. Cal, you want to say bye-bye to 5th graders?